Okay, so the first one wants us to find the degree of the function. So all we need to do is look at the exponents. So we don't have to multiply it out. We just look at the exponents, we add them. So we see that the first exponent is 3 and the second exponent is 2, so our degree of this polynomial is 5. List the zeros. Well, it already came factored, so that's really nice. So we're going to say x minus 4 is equal to 0 and x plus 6 is equal to 0. We don't have to mess with the negative 5 because there's no x there. So we'll get adding 4 to both sides, x is equal to 4, and subtracting 6, x is equal to negative 6. And you could check this by putting them back into the equation, and they would have to equal 0. Next, it says the multiplicity. Well, if you notice, for the x minus 4, the exponent is 3, so the multiplicity is 3. And for the exponent of, for the x plus 6, the exponent is 2, so the multiplicity is 2. 2, find all the real and imaginary zeros for the function. So what we're going to do is we're going to count the number of, first we're going to look for the greatest common factor. There is no greatest common factor, but I check that always. And then I factor it. Well, there's 4 terms, so I'm going to use factor by grouping. Okay, so I'm going to make 2 mini problems here. The greatest common factor here is going to be x squared. So I factor that out. And on the third and fourth terms, the greatest common factor will be 4. Now I reunite the 2 sides and I look for the greatest common factor now of the whole thing, and it's going to be 3x minus 1. And then whatever's left over, I put in the parentheses, x squared plus 4. To find the zeros, I set it equal to 0. And then I set each factor equal to 0. And I solve. Well, that one was pretty straightforward. Now this one, a little trickier. Because I'd get x squared is equal to negative 4. If I take the both sides, the left becomes x, but the right, well, I know it's a plus or minus because I'm taking the square root. But the square root of negative 4, well, that's going to be I, because it's a negative 1. Think of this as the square root of negative 1 times the square root of 4. So this is I, and this is 2. So typically write 2i. So it's plus or minus 2i. Number 3. The function they give us is not in descending order. And when we say that, look at the exponents. This is a 2, and this is a 9, and this is a 1 if there's none, right? So we know that if there's not an exponent shown, that's a 1. So we're going to rewrite them in the right order. So let's put the highest one first. So, and then the second highest one, and then the third. So you can see now my exponents are 9, 2, and 1. So they go in descending order. Find the degree. Well, the degree is simply the highest exponent, so that's going to be 9. And the leading term is that highest exponents, the whole thing. And then the coefficient is the number in front of the variable. So it's going to be negative square root of 4.2. Determine if the binomial is a factor for the polynomial. Well, we know that if it is a factor, the root would have to make it equal to 0. So the root here would be, if I set this equal to 0, 1/2. So let's put in this for 1/2 for our input. And when you multiply that out, you'll see it's not equal to 0. So since it's not equal to 0, it is not a factor. That's an it. Doesn't look like it, but that's the word it. Oh. Number 5, for the function. It's a rational function. We're going to find the vertical asymptotes. The vertical asymptote, we know the denominator equals 0. So first, we're going to set the denominator equal to 0. And we're going to solve. That's simply x is equal to 1. That's going to be, we're going to check this. If I put 1 back into my function, so if I put f of 1 into my function, then I'm going to get 1 squared minus 5 times 1 plus 6 over 1 minus 1. So that's going to be 1 minus 5 over 0, which is going to be 2 over 0. You can see that's going to be a vertical asymptote. Anytime we have a number over 0, that's going to be a vertical asymptote. If it were 0 over 0, it would be a hole. Find the horizontal asymptote, if any. I told you bigger on top one button and bigger on bottom 0. So that's here, y is equal to 0. This is no horizontal asymptote. My face-to-face class. So I look at my two exponents, my leading terms, 2 and 1. It's bigger on top. So the exponent on the top is larger. And since that's true, we're going to have no horizontal asymptote. But when you have no horizontal asymptote, you have to look for slant or oblique asymptote, which is part C. And the way we look at that is we look at the numerator, which we call m in the book, right? And the denominator is what we call n. If m is greater than n by 1 degree, then we have an asymptote, a slant asymptote. Okay? Or the way we talk about it in class is that if the top is bigger than the bottom exponent by 1, then we have a slant or oblique asymptote. Well, we have a 2 and a 1. So 2 minus 1 is equal to 1. That's perfect. So our denominator is 1, our numerator is 2. It's 1 degree apart. We're going to have a slant asymptote. And the way we check that is we divide the denominator into the numerator. So we're just doing old-fashioned long division. So I look at only my leading term and I say, what times x will give me x squared? Well, that's going to be x. And then I multiply. So first I divide and then I multiply. Now I'm going to subtract. Now I'm subtracting this whole thing, the whole x squared minus 5x plus 6 minus the quantity x squared minus x. So another way you can look at this is you can just take out your signs and make them opposite of what you originally were going to write. So we said x squared was positive, so I'm going to make it negative. And negative 1 times x was negative, so I'm going to make that positive. And then I'm just going to add directly down. Next, I'm going to bring down. And then I do the whole thing again. So x times what will give me negative 4x? That's going to be negative 4. Then I multiply. So negative 4 times x is negative 4x, but I'm going to make it a positive so I can subtract. And then the negative 4 times negative 1 is a positive 1, so I'm going to make it negative. Okay? And then I'm going to subtract. And I'm left with 2. Now, whatever my remainder is, I just ignore. That's how you do slant asymptotes. And instead, you take your quotient here and you set it equal to y. So my oblique asymptote is x minus 4 is equal to y. Now, I'm also going to show you how to do that as a synthetic division. So if you want to use synthetic division, you look at your divisor here, and if it says x minus 1, you put a positive 1. It's the root. And then you write the coefficients of the dividend. So 1, negative 5, and 6. So those are my coefficients, right? I see those. 1, negative 5, and 6. Okay. Now, the way synthetic division works is the first column you bring down straight. Just write it down, whatever you see. Now you're going to multiply. You're going to multiply this times this. So 1 times 1 is 1. Now you're going to add vertically. So negative 5 plus 1 is 4. And then you're going to do the same thing again. You're going to multiply And you can see that 1 times 4 is 4. Somehow I made a mistake here. Let's see what I made a mistake. See it here, so this should be a negative. So negative 5 plus 1 is negative 4. All right, let's try that. So that's going to be negative 1 times negative 4 is going to give me negative 4. So that looks better. And then 6 minus 4 is 2. Remember, we're adding these going down vertically. So I'm left with 1, negative 4, and 2. The way synthetic division works, it's always going to be 1 degree less than the original dividend. So our original problem was x squared minus 5x plus 6. So this is going to be an x, 1 less exponent power. And this is going to be minus 4 plus 2 over x minus 1. Okay? But we know for oblique asymptotes, we ignore the remainder and we set it equal to y. So it's going to be the same answer whether you do it with synthetic division or with long division. Okay, clean this up. Next, solve the inequality and write the solution in interval notation. Okay, there's several ways you can do this. One is you can use your calculator to help you find those zeros. Okay, but you can do it the old-fashioned way and just try to factor it. Took out the greatest common factor, and then I kept factoring. So I can see that my zeros are going to be 0, 7, and negative 3. Now there are several ways you can do this. One is you can simply graph it on your calculator. Okay, that's one way you can do this. Another way you can do is you can do a test point. A little hack that you can use by hand or put them in your calculator. You can what you do is you just put your function into your calculator where it's set remember it has to have 0 on one side, and then we're going to say second graph, and when we do that, that opens up the table, and that gives you all the inputs for the different with different outputs. So a negative 5, I just go up to negative 5. It says negative 120. I don't really care what the number is. All I care about is the sign. So that's going to be, so you can see it, negative 120. Really what I'm looking for is whether it's positive or negative. And then if it's a negative 1, that's a positive 16. And then at 1, it's a negative 24. And at 10, what's clearly negative, a positive 390. Okay, so that's one way of doing this. You can also, though, just do it with the graph. So I entered my function in. If I hit graph, it's going to show me what it looks like. So you can see that it's going to go up and then down and then up. And that agrees with our negative, positive, negative, and positive. But you don't even have to do that part. You can just do the graph itself like that and just skip this part, right? If you have this, this tells you where it's a negative and where it's positive. Okay, so I'm going to erase this. So now we need the solution. So we have to look at the sign. What is our inequality sign? Well, our inequality sign is less than, right? So when it's less than, we want to go below. We want to go below the x-axis where it's negative, right? And you can see that it's negative here in this region. Let me color this for you. So you can see it's negative here, and it's negative here. Well, that would also match the signs we did on our table. But do you see, just by graphically, I can see it's below the x-axis, right? So the way we describe that is we use the axis. We say that's from here to here. So our solution is going to be negative infinity to negative 3. Now, since it's a less than, it doesn't have an equal there, we're going to put a parentheses. If it were less than or equal, we'd use a bracket. And then from 0 to 7. Okay, so let's do number 7. This is a rational inequality. So when I have a rational inequality, I'm going to set the denominator equal to 0. Okay, so say x squared plus 10x plus 21 is equal to 0. I'm seeing what numbers are going to be kicked out of my domain. So x cannot equal negative 7 and x cannot equal negative 3. Okay? Next, I'm going to set my numerator equal to 0. So x minus 1 is equal to 0. So x is equal to 1. So these are the numbers that I'm going to look for on my number line. So I have negative 7, negative 3, and 1. Before, I tend to use my calculator to help me, or I can use a table with for each interval. So I'm going to do this. I'm going to pick x's that are in each interval. So I can pick a number, any number that's on this part of the number line. So I'm going to pick negative 10. And then I'm going to do any number that's on this part of the number line. So I'm going to pick negative 5, any number that's between negative 3 and 1, 0, and any number that's bigger than 1, I'm going to pick 5. Okay. I'm going to use my calculator. Now, when you're putting this into, you don't have to, you can do it by hand, and all you're looking for is the sign. Okay, so an easy way to do this, for example, if I put it in a 0, it'd be, I'm thinking this. So I'd get negative 1 over 21, which is negative. All I need to do is the negative part. I don't need the number really. Or I can use my calculator, and I have the calculator. Now, when you're entering a rational function into a calculator, big, helpful, there'll be a little Easter egg here, okay? So when you're putting this into the calculator, make sure you put a parentheses around the numerator and the denominator. That way you're safe, and that way the calculator knows that the x minus 1 is the numerator and the entire polynomial x squared plus 10x plus 21 is the denominator. If you don't, if you just enter in the calculator like this, your calculator thinks that you're doing this. It thinks you're writing, oh, it's just going to be the x squared. And that's not what you intended, right? So we're going to make sure that we put a parentheses set around the numerator and the denominator. Okay, so open up those calculators, and let's, an easy way to do this is to check your table. So I went ahead and entered my function in already, okay? And now I'm going to hit second graph, and that gives me the table. So I'm going to save myself putting it in. I'm going to check at negative 10, and let's go all the way down to negative 10. Oh, lost my calculator. Oh. Don't know what happening there, but at negative 10, you see I get a negative number. So I'm looking for, I got negative 0.5238. I don't really care. All I care about is the negative part of it. Okay? It's negative here. And then at negative 5, I can enter it, or I can just go to my calculator. I get a positive 1.5. Right? That's 1.5. And at 0, I have a negative 0.0476. And then last but not least, at 5, I have a positive. Okay. Now let's just take a peek at the graph too while we have the calculator. I'm going to draw this in a different color so you can see what it looks like. All right, so if you just looked at the graph, let it help you. You know, that's what these calculators are for. So you can see what it looks like, right? So you can see that it's down here, right? And then it's up here. And then it looks like this, okay? And it must change over. I know it doesn't look like it on the calculator because you can't really see what's happening, but it actually must go like this. Because you can see it goes from negative to positive. So at this one, and we know that because we said that, let's see, we said that this is actually going to be a 0. This x is equal to 1. If you can check that out on your graphing calculator too by looking this up, you can see there at 1, it's not an error, it's 0. That is a 0. So where your numerator equals 0, that's going to be a 0. So it crossed over there. So now, back to the way we did it earlier, we know that if it's less than, oops, that obliterated that, but if we have the sign less than, we want places that are below the x-axis, the negative areas, okay? So let's see what our solution would be. Our solution then would be, for instance, negative from here to here, and from here to here. So the temptation would be, like when I just wasn't paying attention, I might go, oh, wait. My answer then would be from negative infinity to negative 7 in union with negative 3 to 1. But remember, we said that x cannot equal negative 7 or negative 3. Okay, so you have to be careful and make sure that you're excluding those values from the solution. Well, in this case, it didn't matter because we didn't use a bracket error, but I'm just saying always go back and look to make sure that if this had been less than or equal, sometimes people want to put a bracket there, and then they realize later that they should have excluded any values that are not in the domain. But since ours was this less than, we didn't have to worry about that as much. So be careful if you do have an equal. All right, so that's our solution. I'm just realizing too, we skipped 4D. So let's go back and look at 4D. 4D says the domain. Well, the domain, we know that we're just going to set the denominator equal to 0. So you always set the denominator equal to 0 and solve. Whatever your solutions, they get removed from the domain. They're the bad solutions. They're going to make us have division by 0, which would be undefined. So we say x minus 1 is equal to 0, so x is equal to 1. So our domain is equal to x cannot equal 1, or you could say all real numbers except 1, or you could say negative infinity to 1 and put in parentheses, and then 1 to infinity. That also excludes it. I really emphasize that domain, when you find this value, this is not your domain. These are the numbers you don't want to have in your domain, okay? Because if you put back in a 1, then you're going to get, we talked about 2 over 0. We do not want 2 over 0. We never want to have division by 0. So this is going to happen. This is going to tell us what numbers are removed. And if you notice, these are happening at our vertical asymptotes. Okay? They're also going to be holes. You're going to check. You're going to kick out any number that makes the denominator equal to 0. Remove it from the domain. We call those domain restrictions. All right, let's go back to where we were. Sorry about that. I just realized that when I was looking at it. Number 8. Is this a function? Explain why or why not. Well, when it's a graph, this is an easy one. We know that the vertical line test tells us if it's a function or not. Well, it passes the vertical line test. You can see, right? If I put a vertical line anywhere, it only happens to cross at one time at one place at a time. So yes. And why? Because it passes the vertical line test. Okay, now let's check 1 to 1. Well, this one's easy because we're just going to check the horizontal line test. So you can see it passes 3 places. So it is not 1 to 1 because it fails the horizontal line test. Then it says state the relative maxima and minima. Well, we're just looking for the highs and the lows, the peaks and the valleys. There's one there, one there, one there, and one there. Okay, so we're going to say -3, 1, -2, 2, 0, and 3, -3. And then when it says absolute maximum and the minimum, that means in the domain where is it the highest and lowest. Well, you can see the highest point would be here, and the lowest point would be there. So our absolute minimum will be 4, 4. And our absolute minima, our absolute maxima is 4, 4. And our absolute minima is 3, -3. What's our domain? Well, our domain is as far left to as far right as we can go. Okay, so what's the farthest left we can go? Well, it's -4. And what's the farthest right we can go? It's 4. So our domain is -4 to 4. And wait, oh, those are going to be brackets, aren't they? So if we have a closed circle here, we know those are going to be brackets. Okay. Our range is our lowest to our highest. Well, our lowest point is down here at -3, and our highest point is at 4. So our range is going to be from -3 to 4. We always put the low value first and the high value second. Is a function even, odd, or neither? A couple little tricks we can do, and then we're going to do it the mathematical way. So let's look at that first. So we know that x is equal to f negative x. So we know y is another. We say that x is the same thing. So let's put in a negative x. Where do we see an x? That would be 5x to the fourth minus 3 squared. Well, you notice that's what we started with. So f of negative x is equal to f of x. So it is even. Mathematically an even function. But I told you there's a little hack that you can use. So you can use your calculator for this one too. So you can put it into your calculator, right? Under the Y1, the grapher. And then you can just graph it. Let's take a peek and see what it looks like. You can see that our function is symmetrical about the y-axis. And we said that's an easy way to see if it's an even function. If it's symmetrical about the y-axis, it mirrors itself, then it's even. Well, so that one's even. And on the exam, you're just going to tell me even, odd, or neither. It's not going to be defended. Okay? Similarly, let's look at b. If I get a y equals, let me just put in b. Okay, so I put in the function. I'm going to graph that. And I told you a quickie way to do this one with the graphing calculator is you just turn it upside down. When you turn it upside down, if it looks the same, then it's an odd function. Okay, so let's take a peek at this. My calculator, well, let me turn it upside down, but I'm gonna use this. I snipped the screen. Okay, so what I mean by that is you're just gonna turn it upside down. Whoops. So let me turn it upside down. Seemed like it was gonna be easier when I thought about doing it with the snipping tool. Okay, then not as easy as I thought to do on the computer here. But it is easy to do with your hand because you just flip your hand upside down. Okay. Almost there. There. All right. So you can see it's upside down now. And it looked identical to it did when we started, didn't it? So if you turn your calculator upside down and it's the same function, then it's an odd function. Okay? So this is going to be odd. Let's prove it though mathematically too for people who want to do it mathematically, so I'll delete that. So for example, to prove that something is odd, well, first I have to check to see if it's even. We'll just check. If I put in a negative x for x, I'd get 4 times negative x cubed minus 2 times negative x. This would be 4, and that would be negative x times negative x. That would be negative 4x cubed, and this would be plus 2x. You can see this is not equal to f of x, not my original function, so it's not even. I can see that, right? Because of f of x is not equal to negative f of x. But now I'm going to try the next thing. I'm going to say, let me just put a negative in front of my function, okay? And see what that would be. So that would be negative times 4x cubed plus 2x. It's going to be negative 4x cubed plus 2x. And now let's check that, comparing it to f at negative x. Well, you can see these are the same. So when f at negative x is equal to negative f of x, we know this is an odd function. So you're welcome to do it mathematically or to use the calculator. Either way is fine in the final. Number 10, for the piecewise function. Remember, a piecewise function is just 3 little functions on the same graph. So the trick is knowing which piece to use. This is not hard. We know that x is our input. So we look at our input for each of these. When it's negative 3, right, it's going to fall under this one. X is less than negative 2. So we're going to use this equation, negative 2x minus 1. But in place of x, I'm going to write negative 3. So 6 minus 1 is going to be 5. Okay? Our next input is negative 2. Well, negative 2 is not less than negative 2. Since I have the equal sign here, I'm going to use this equation. So, well, it's just a number. When it's just a number, that's just a number. It's a constant. It means that is a constant value for anywhere between negative 2 and 5. Well, 0, our next one, that's between negative 2 and 5. So it's also going to fall into that middle function. And then last, when x is 6, well, but 6 is definitely greater than 5. So we're going to use this function, so x squared. So that's going to be 6 squared or 36. Okay, number 11. This is simply a graphing formula, a graphing problem, and it's just asking us, do we recognize what this is? We do. It's a circle, right? A circle. So we know that the center is going to be negative 3, 1. Okay, we're going to look at these. Now, quadratic, what we said, x lies and k tells the truth. I'm sorry, h lies and k tells the truth. But on a circle, they both are lying. Whatever you see are lying. This is a minus 3, and a minus 1 is a 1. Right? Easy way to remember it. Because our formula for a circle is this, right? So h and k are our center. And then our radius, remember, this side over here is going to be r squared. So r squared is equal to 25, right? I mean, r is plus or minus 5, but we know radius is a distance, so it can't be negative, so it's just going to be 5. So our radius is 5, so we can just graph that, not a problem. I graph my center at -3, 1. And then my radius is 5, so that means I'm going to go 5 to its right, 5 up, 5 down, and 5 to its left. So 1, 2, 3, 4, 5. And then I can circle it. And that's all I'm looking for. I'm not looking for any more than that. Just can you graph it? That's the meaning across. Now, we're not done though, are we? Okay. Actually, we have to be very careful on this one because it says less than. Now, first of all, that means that we're going to make this be dashed, right? Because less than means it doesn't include the circle. So you can use your eraser. I don't have one that works well for this, so I'm just going to make myself little dashes here just so you can get the idea, right? Okay, so you can see that should have been dashed, right? And then what I want to do is I want to use the test to decide, do I shade inside or outside the circle? Okay, so I'm going to use a test point of 0, 0. I always use 0, it's the easiest one you can do. What that means is I put in a 0 for x and a 0 for y. So 0 plus 2 squared plus 0 minus 1 squared. That's going to be 9 plus 1. Is 10 less than 25? Yes, it is. And since it is, that means that 0, 0 is part of the solution. So if it is part of the solution, then we're going to shade wherever 0, 0 is. If it weren't, we'd shade to the other side. That means we're going to shade this side. It's quadratic. You can solve it wherever you want. You can use a calculator. You can use quadratic formula. You can use, I'm going to use factoring. So I say that I see 14x. My factor. I see 0. And I solve. So this is going to be x is equal to 0. That's 1, 0. And x is equal to 1/2. That's my second 0. Okay, but you may use any method you want. If you wanted to, you could set that up in the calculator. But y2 is equal to 0, and then use the second base 5 intersect method to find the zeros. You could use the quadratic formula. A would be -28, and B would be 14, and C would be 0. Okay. Elizabeth designs and sells ladies' neck scarves and specialty scarves. The cost of the operating her business is given by a function where X is the number of scarves sold. How many scarves must she sell to minimize her costs? Whenever you see the word minimize or the word maximize, you know that it's a vertex. Let me just remind you of that. Whenever you see maximize or minimize, you're looking at the vertex, right? That's the maximum minimum points. So you want to review the formulas for maximum and minimum for the vertex, right? So if it comes to us in vertex form, well, we love that because we can use our eyeballs and we can see that H lies, K tells the truth. So our vertex is 25, 90. But what does that mean? Well, X is the number of scarves sold. Okay, so that means 25 scarves. And then Y is the cost. So that means $90. So that would be the minimum cost. But I remind you, it doesn't always come in vertex form. Sometimes it comes in standard form. When it comes to you in standard form, you must know the formula for the vertex. So we know the vertex for a standard form, H is going to be -b over 2a, and then K is going to be, you put back in H, right? So make sure you memorize this, and you know when it's in vertex form or in standard form, okay? And remember that the word minimize and maximize means vertex. Number 14, solve the system by graphing on your graphing calculator or by hand. Your choice. Or you can solve this with substitution. I'm going to do it both ways. So first of all, substitution. Since y is equal to this, my y. So x squared plus negative x minus 1 squared is equal to 5. This is using substitution. Just expand that out. 2x squared plus 2x plus 1 is equal to 25. And then I'm going to use the zero factor property. And I'll get my solution. It's negative 4 and 3. Now, this is only the x coordinates. Now I need to put them back in for the y's. So I know negative x minus 1 is equal to y. So if I put in a negative 4, I'm going to get 5 minus 1. So y is equal to 4. So that one's going to be negative 4. Oh, silly me. That should be a 4. 4 minus 1 is 3. That looks better? That looks better. Okay, that's one of my solutions. And then I have to do the other one. So negative x minus 1 is equal to y. This time I'm going to use 3. So it's going to be 3 negative 4. Okay. Now let's do it with the graph. Our first equation is simply a straight line. So it's going to be at negative 1 is my y-intercept, and my slope is negative 1. Okay, there's my first line. I'm going to pencil it in here. Okay. Now my second equation is a circle. Don't let it fool you. All it means is that your center is at 0, 0. So my center is 0, 0, and my radius is 5. Now you may say, oh wait, here's the solution, one there. And here's another solution, one there, right? We say, oh, I'm not sure. What if I got it wrong? What if I got it wrong? Just check it. Put those numbers in and make sure it's a solution. So I'd put in 3, negative 4, and yes, it would make a solution for both. And I'd put 4, negative 4, 3, and yes, it would be a solution for both. So you can always check your answer if you're feeling unsure about graphing. Okay? Find the zeros on your calculator. So get those calculators out and enter this into your Y1 grapher. I went ahead and did that. You can see I'll back from the beginning. I entered mine in. Okay. Oh, and I can see I have a mistake here. This should be a 4. Just checking. Okay, now we're gonna say second. Oh, before we do that, we always have to use y2 is equal to 0 when we're looking for zeros, right? So if you keep getting the wrong, you don't get an answer, like it's not working, it's because you forgot. Use intersect, we're basically saying that x-axis, that's y is equal to 0. So we have to see where it intersects. We need 2 equations. So second, trace 5. Okay, and it's going to give us a graph. Give it a second. And then you can see I have 2 zeros. So enter, enter, enter. I'm looking for those real zeros. So I get 3.553. Or it says 2 decimals, so 3.55. Now to get my next one, I'm going to do the same process again. Second, trace 5. But I stop here. Don't hit enter, enter, enter. It's going to keep giving you 3.55. Instead, I'm going to use my left and right arrow key. It just moves it along my function. Anywhere near my 0. It doesn't have to be exactly on it, but near it. and then hit enter, 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 and I'll get negative 1.35. Those are my two zeros using my zeros of my calculator. You know, those are just my real ones, though. No imaginary ones. For the calculator, you can only find the real ones that way. Now, to find the inverse, we just did this on the last test, so hopefully this is fresh. All we need to do is we know that this is another name for y. Now, to find the inverse, we're going to swap x and y. Right? Now, we're going to solve for y. Okay, so I'm going to multiply times the reciprocal, both sides. And I'm going to get 4/3 x plus 4 is equal to y. But I wasn't really looking for y. I want to call that inverse of x. Okay, so 4/3 x plus 4 is the inverse. Okay, now we're going to look at composition of functions. When it's just f minus 5, or f plus 5, or f divided, or f multiplied, we're just doing it the way we would think. We'd say that's just going to be f of x minus g of x. So 4x plus 1 minus 3x minus 2. Whenever it's minus, though, remember to distribute that minus both terms that follow it. So I'm going to get x plus 2. And what is the domain? Well, the domain of this is simply all real numbers. So for minus and plus, when you're adding and subtracting functions and multiplying, you don't have to worry about that unless they're fractions. If they're fractions, you have to always remember to remove the number that will cause division by 0. Or if they're a square root, you have to make sure that you always remove any number that will make the square root, the radicand, less than 0. Okay? You want to have that radicand greater than or equal to 0. But most of the time, it's just going to be a straight, we're just looking at each function, and whatever domain is will be our domain. Number 18. Okay, so f and g, this time it's a composite function. So in composite function, you're going to put g and f. So this. So this goes in place of this x. Right? So you can think of it like this if this makes more sense to you. Your input instead of x is going to be x plus 6. So it's going to be 3 over x plus 6 plus 5, which is 3 over x 7. That's our answer. And it says, what is the domain? Now, our domain, we always want to look at g of x. Well, our g of x is just all real numbers. But let's look at this composite function. We know that the domain has to be all real numbers except negative 11. Number 19, half inverse. Oh, it should be an easy one. 0, 3. And this one's going to be 1, negative 1. And I actually gave you the points. I'll do the same thing on the final exam. You can pick off other ones if you wanted to. But write them out and then say, well, I'm just going to swap x and y. So this is going to be 3, 0. And then negative 1. Oh, it's going to be negative 1, negative 1. So negative 1, negative 1. It didn't change, did it? Okay, now, I noticed on the last test, a lot of people get confused. Maybe some other system that you give yourself a little, like this or something, so you know which ones you're going to make the lines with. Because sometimes people use the other dots instead of the new dots. So, okay, so this is going to be our inverse right here. Okay, now, that wasn't hard. Label it. So put on there like this. That tells me which one it is. I know you know which one it is. That's the inverse. The line of symmetry is always the same. Okay? So B is going to always be y is equal to x. For any inverse, that's always going to be the line of symmetry, which we know is just the identity function. Oops. Whatever you put in, you're going to get out. And that always is a 45-degree angle. So just label it line of symmetry. That's all you need to do. Number 20, solve the exponential equality property. Solve using the exponential equality property. In other words, you want to have the same base. So we know that if you have the same base, then A equals D, right? You have to have the same base. We don't have the same base, do we? This have a base of 7, this have a base of 49. It does not work. I need the same base. But I have to ask myself, can I draw that? Can I write 49 as a base 7? Can you write 49 as base 7? Sure, it's just 7 squared, right? Use your calculator to help you if you're having issues with that. So 7 squared. So I replace 49 with 7 squared. It means the same thing. Okay, so now I'm gonna say, well, I want my bases to be the same. I have that. I'm going to distribute 2 because that's how a power to a power works with exponents, right? And now I have the same base, so I can set those exponents equal to each other. And then I can just solve. So I'm going to subtract 2x, and I'm going to subtract 2, and I'm going to get negative 7 is equal to 4x. So x is equal to negative 7/4. Number 21, solve the exponential equation. When you're solving an exponential equation, it's always the same trick. You write it as a log. If you want to solve a log, you write it as an exponential equation. But before you change it into the other form, make sure it's just a log or an exponential equation, an exponential expression by itself. So in other words, I'm going to choose those sides. And then I'm going to divide by 3. I want to get it so that it's b to the x is equal to a number. Once it's in this form, I can just rewrite it, okay? So I know that for an exponential expression, this is the base, right? And the superscript is always my exponent. Label them. It will really help you. So now I'm going to rewrite it, log. Now remember, the little number here is always the base, and a log is another name for an exponent. So the exponent always goes on the other side. Okay, so I'm going to put 2x, and then it's base 5, and then the argument will be 3. That's the hardest part, setting it up. So now I'm just going to realize, wait, I don't have a log base 5 on my calculator, but I know the change of base formula. The change of base formula says that all I need to do is I put the log of the argument over the log of the base. And the way I remember that is base goes on the bottom, B, base, bottom. Okay? Now, I want this, and I want x to be by itself, to divide both sides by 1/2. Okay? And when I put this into my calculator, I get 0.341. Well, let me check my answer sheet that I did. So, yep, that looks right. So if you're having problems with that, let me know, putting in the calculator. But the log button we know, just to remind you, is right here, over here, log. It's a log of 3 and divided by log of 5. Hit enter, and then I'm going to divide that by 2, or multiply times 1/2, either way, and I get 0.341. Okay? Now, our next one is also the same exact problem, just the opposite direction. Okay? So I want to get the log by itself. So I'm going to divide both sides by 22. That's 1/2. And then it's going to be equal to log base 5 2x plus 1. Okay? Once it's in the log by itself form, label it base exponent. A log is another name for an exponent. So the exponent is always on the opposite side of the log. So now I'm going to rewrite it in exponential form. So my base is 5, my exponent is 1/2, and it's equal to 2x plus 1. So this is the square root of 5 if you wanted to do it that way. Okay? So this is the square root of 5. So I can subtract 1 from both sides. And I can divide by 2. Now remember, you have to make this be a plus or minus if you're going to do it. Whoops. If you're going to do it this way. This is the square root. Okay. So you can do that. And you're going to get two answers. Let me save myself putting them in. So I got my two answers, negative 1.618 and 0.618. So negative 1.618 and 0.618. Okay. Now, you have to remember to check whenever you're dealing with logs to make sure that you haven't created an extraneous solution. If I put in negative 1.618 back into this argument, you'll see that I'll get a negative. And I never can have a negative, take the log of a negative number. It's not in our domain. So we're going to cross that one out. Okay. Now I'm going to do it the other way, just so people see it both ways. Maybe you don't like that way. Maybe you want to do it this way. You're going to square both sides to get rid of that 1/2. That's okay too. So 5 is equal to, and you'd get 4x squared plus 4x plus 1, right? Which is 4x squared plus 4x minus 4, which is going to be x squared plus x minus 1. This is not a factor, though. You're going to have to use the quadratic formula, or you're going to use your calculator to find the zeros. Let's just use the quadratic formula for fun. A is equal to 1, B is equal to 1, and C is equal to negative 1, just to review it. So we know the quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm just going to fill in. Okay, so I get negative 1 plus or minus the square root of 1 plus 1 plus 4 is 5 over 2. You see, we get the same exact answer we got earlier. We're going to end up with the same negative 1.618 and 0.618. And once again, you have to check the extraneous solutions. And the third way would be is to use the calculator and to find the zeros of this same x squared plus x plus minus 1. So you can use your calculator if you wanted to, and you're going to get those same two solutions, and you'll do the ending the same way. So really, at this point, I hope you're seeing that you can use several different ways to solve a quadratic. And on this test, I don't care. You may use whatever way you like. Number 23. Sorry about this. I realized after I was working at you last night that I had a typo here. This should be base 2. So go ahead and make it on your problem before we start. That change. Now we're just seeing if we know the properties. We know that log of x plus log of y is equal to log of xy. That's the first one. Log of x minus log of y, that's equal to log of x divided by y. And the third one is x times log of y. That one, you just move the number in the front as the exponent. So those are a couple to review. What do we have? Well, the first thing I always do is I start over here and I start combining with n. So this is going to be log of 2, and then whatever's inside here, I'm going to raise to that exponent that was in the front. Now, since they're added, I'm going to multiply them. Same base. And this could be x cubed and x minus 2 cubed, right? So combining them as much as possible, I'm going to make x minus 2 to the 4th, and then x cubed. Number 24, rewrite as a function with base 10, use your calculator. The change of base formula we said was the log of the argument over the log of the base. And you can use your calculator and you will get, look at my cheat sheet here, I got 1.893. Okay. Number 25. This is going to become compound continuously, so you need to make sure you know this formula. A is equal to P e to the RT, where P is the principal, R is the rate, and the decimal, and T is the time in years. All right, so that's what we have. Write my formula. And now I'm going to write my P as my principal, so 12,500. My rate is 2.75. That means percent means out of 100. It's an easy way to remember it. That's going to be 0.0275, and my time is 4 years. So I put that in my calculator, and I get, let me cheat and look at my answer. Okay, so let's just make it 13953, $1,953.48. I made it to cents because that's what typically we think about. We want to go to the penny on money. Okay. Okay, so we're going to solve the exponential equation. Same way we've done it earlier. We're going to rewrite it as a log. First thing I want to do is isolate it though, which means just get that base to the exponent alone on one side. Oops. All right, so now we have e to the negative 3.1x is equal to some number, which I'm just going to leave as a fraction. Okay. Now, label each part. It will help you. This is the base, and this is the exponent. We're going to rewrite it as a log. So log base, the base goes here. The exponent is on the other side. A log is another name for an exponent. So our base is e, and our exponent is negative 3.1x. And I put my argument here. Okay. Now, remember, log of e, that's just a way you can say natural log. So on your calculator, you'll see there's a natural log button here, right? So I'm entering in my argument. And now I'm going to divide by negative 3.1. And I get negative 0.827. Okay, so to make sure you see this, I divided this by negative 3.1. Remember, that's going to go, that is not inside the log, that's outside the log. And our answer was negative 0.827. Find the inverse of the log. So we know that this is a fancy way of saying y. Find the inverse, we swap the x and the y. Okay, then we label the parts, base. Okay, a log is another name for an exponent. So we're going to say 4x is equal to y. But we don't want to solve for y when we're actually solving for the inverse. Okay, number 28. We've done these all this semester. Hopefully you figured this out by now. So this is the square root of x is equal to y. A basic function means it doesn't have any of the negatives or the minuses or the pluses. It's just a basic function. Again, the transformation, when there's a minus in the front, tells us to reflect about the x-axis. When x has something with it, it says minus 4. That means we're moving right 4. And then if there's a number on the end, that tells us it's going to go up or down. So it's going to go, whoops. It's going to go up 5. Okay, and our last problem is a word problem. It's an exponential problem. So I'll give you a second to read it. Okay, so hopefully you read it and you see that this is the value. It's an equation. And you can see the exponent tells us that it's decreasing in value because it's negative. Right, so it says T represents the year since 2004. So it already gives our T. Remember, it's since 2004. What year will his car value drop to approximately $130,000? So I'm going to replace V sub T with $130,000. And then this is the exact same problem, basically, as we did a minute ago. So doesn't this look a lot like the one we just did on number 26? Pretty similar. So I want to isolate my exponential. And now I want to label it. So this is my base. And this is my exponent. That's going to be log base E equals to my exponent. I think I'm missing a digit here. Let's fix that. So it's 220,500. Okay. So I know that log base E is a name ln, natural log. Then when I get T alone, so I'm going to divide by 0.065. Remember, I put it on the outside because that's not inside the log. Okay, let's use my calculator and see what we get. So I say natural log 130,000 divided by 220,500. Enter. And then I'm going to divide that by negative 0.065. Oops. And I get 8.128. Okay, but years we know come as wholes. So if it's going to be 2004 plus 8.2, that's 2012.2. So that means it's somewhere in the year 2012, maybe like in the spring of 2012. So in 2012, the car value drops below $130,000. So that's our last problem on our final exam practice. So repeat after me. I can do this. Do some more setting. Make sure that you bring your 3x5 card. You can have writing on both sides. That's fine with me. Make sure you bring your graphing calculator. If you don't have one, check one out at your campus. I'm building an East Campus that I'm building for, but ask. If you don't know, ask the testing center when you go in, ask them where you can check one out, and they'll be able to refer you to the right place. Make sure you give yourself plenty of time. If you're an online class, to get to the testing center, or the hybrid to the testing centers. My face-to-face class, I will be meeting you in the classroom. But for my hybrids and my onlines, you guys are in the testing centers. And for my face-to-face, you're going to be in the classroom.